So section 4.4 is going to deal with radicals, or sometimes we call them roots. We're going to be seeing this kind of symbol. That particular symbol is a square root symbol, hence why we say or roots. Not that I could spell. In a generic square root symbol or a general radical expression, a problem that has a radical without an equal sign, there are components. This symbol itself is actually called a radical or the radical. If there's a variable or some sort of expression under the radical, that's called a radicand. Most radicals have a little number that's written either in this cup or directly above this cup in a smaller font, but square roots don't. In square roots, there's an implied number that is going to be, that I'm going to write here in a second in my little cup, and it's really unusual because normally when there's an implied number in mathematics, that number is 1. It's not for square root symbols. In square root symbols, the number that's implied in that little cup or slightly above that little cup is the number 2. And that number 2 is called the index. So every radical expression has 3 parts: the radical symbol itself, the index, and the radicand. When I look at just a generic radical expression, like this. In this one, the index is 3, the radicand is 8. I would read this as the third root of x. Because this is a common index 3, we have a common name for it. Instead of saying the third root of not x, the third root of 8. Instead of saying the third root, we might say the cubed root. Those words are going to be interchangeable. If I wrote something like that's a fifth root. Fifth roots don't have common names. I would read this as the fifth root of 243. Reading doesn't have a lot to do with what it equals to. Any root problem is asking the question, what number raised to the index power equals the radicand? So the cube root of 8, whatever this equals to, it has to answer the question, it has to be the answer to the question, what number raised to the third power equals 8. And you might know that just naturally. You might know that 2 to the third power is equal to 8, so the cube root of 8 is going to be equal to 2. If you don't know, I don't expect you to memorize a bunch of radicals. We're going to use our calculator. So if I don't know what the cube root of 8 is, on my calculator, above the square root symbol, there's a cube root symbol, and then, I don't know what color to call that, kind of orangey color. To activate the cube root symbol on my calculator, I first type the shift key, and then type the square root key, and there's a cube root. And my calculator will answer the question for me now. Tells me the cube root of 8 is 2, because 2 to the third power is equal to 8. This fifth root of 243, this is asking what number raised to the fifth power equals 243. I can't imagine a lot of you know that. That's not very common. There's not a fifth root key on my calculator because it's not that common of an index. Square roots and cube roots are common. On the exponent key above it in that orangey color is a key that will allow me to find any index. If I go shift and square root, or shift and exponent should I say, I activate a template for any index. So now I can type a 5 in the index, arrow over, and type 243 in for the radicand. And my calculator would tell me the fifth root of 243 is 3. That's because 3 raised to the fifth power is 243. The answer that I'd write to a fifth root problem is going to be the number that raised to the fifth power equals the radicand. The number that I would write as an answer to reducing a cube root problem is the number that's cubed that equals the radicand. When we deal with negative numbers, it depends. Negative numbers are tricky with radicals, and what kind of answer I get depends if the index is odd or the index is even. So in the world of odd indices, I wrote a couple problems here. I wrote, what is the cube root of negative 64? Here, the index is odd. The index is 3, which is an odd number. And the radicand is negative. This is asking the question, what number cubed is negative 64? I'll pretend I don't know. I'll hit shift and square root, use the negative by the fraction and type 64. My calculator says the cube root of negative 64 is negative 4. That's because if I cube negative 4, I get negative 64. Similarly, if I did the fifth root of negative 32, here the index 5 is odd, the radicand negative 32 is negative. If I do shift and exponent key, type my 5, get ready to type the radicand, type my negative, and then type my 32, my calculator tells me that the fifth root of negative 32 is negative 2. That's because negative 2 raised to the fifth power is negative 32. So in general, if the index is odd and the radicand is negative, the radical reduces to a negative number. So in general, if you have an odd index, I did an index of 3 and an index of 5, and a negative radicand, I did a radicand of negative 64 and a radicand of negative 32. It reduces to a negative number. The next group of problems have even indices and negative radicands. And let me show you what happens. If I try to do the fourth root of negative 16, this is asking the question, what number to the fourth power equals negative 16? So if I did this on my calculator, shift, exponent button, fourth root, negative by the fraction, 16. My calculator gives me a math error. Why does it give me a math error? Because no matter what number I raise to the fourth power, it becomes positive. Any number to the fourth power, because 4 is an even number, no matter if I raise a negative number to the fourth power or a positive number to the fourth power, I get a positive number. There's no number, technically no non-made up number, no real number that I can raise to the fourth power and get negative 16. This right now, I might say there's no solution for this. In terms of the numbers that I just can't spell solution, I guess that's okay. In terms of the numbers that we know now. A little bit later in the chapter, we're going to learn a made-up number called I, the imaginary number. And we're going to use it to find square roots of negative numbers. If I look at the next problem I wrote, the square root of negative 49, type the square root symbol, type the negative by the fraction, type the 49, my calculator gives me another math error. The reason is because I'm looking for a number that when you square it, you get 49. Well, no matter what number I can think of, if I square it, it's going to become positive. If you square any number, that number is going to become positive. There's no solution. There's no number that I could square. There's no real number that I could square to get negative 49. It turns out that this, we'll learn a little later in the chapter, is actually a make-believe number called an imaginary number. But in general, if you have an even index and a negative radicand, there's no solution, at least no real number solution. You can make up solutions. So if you have an even index and a negative radicand, it's more proper to say there's no real solution because there's no real number solution. There's actually a made-up number solution that we're maybe unaware of right now. But saying there's no solution is not technically wrong for our knowledge base right now. That's a big deal. Everything on this sheet's a big deal. Just understanding how radicals work. I've already spent 12 minutes and I haven't got to any of the problems yet because the theory is important. 2 more bits of theory and then we'll get to some problems and then we'll finish a part 1 and then we'll do a part 2. The square root symbol that I'm used to seeing, and it's the only square root symbol I know, we call the principal square root symbol. And this principal square root symbol wants positive answers. It is actually asking the question, what positive number squared equals the radicand? So the square root symbol is called the principal square root symbol. And it very specifically wants my answer to be positive. This is because we don't want multiple answers. Like if I wrote the square root of 25, if this allowed negative answers, it technically, well, it is true that both of these numbers satisfy if you square them, you get 25. And because with square roots, if you square numbers that are opposites, they equal the same value. We don't want to have that confusion. And so the square root symbol, even though there's 2 numbers that fit what they need, I need my answer squared to be 25. The square root symbol only wants the positive value. A little bit later, I believe in chapter 5, we're going to want both the positive and negative square roots. We'll want more than just the principal square root. And if you want both the positive and negative square root, this is when we use a plus or minus symbol. And if I wrote this problem, this says I want both the positive and the negative square root of 25. We'll get to that later, not in this chapter. So one more bit of groundwork and then we can worry about some problems. In terms of orders of operations like radicals, we treat radicals like exponents. I think it's the next section, it might be 2 sections ahead of us. We'll learn that radicals are related to fraction exponents. We'll even learn that a little bit in this section, but not as clearly as we're going to learn it further down the road. So if I had this problem, 8 times the square root of 25, I don't have a times sign between the 8 and the square root symbol. That's another one of those times that would be implied. But my orders of operations would be to do the radical first. I'm going to treat the radical like it's an exponent. And then I have a times, and I'll consider something an exponent when I see a radical. And so to simplify this, I would do the radical first and then the multiplication. My calculator can do this all day. My calculator knows the orders of operations. I can go 8 times the square root of 25. If I'd have put the times sign in and did 8 times the square root of 25, it also would give me that. There's some stuff that my calculator is really clunky on entering. If I want to do 7 times the 5th root of 32, on my calculator, I can't go 7 and then shift template for the 5th root because it makes the index 7. It's programmed. If I type a number in, it wants that to be the index. If I want to enter 7 times the 5th root of negative 32, my calculator, I have to fight it. I have to enter the problem with the times sign that's implied. If I put the times sign in that's implied, I won't have this issue. I won't go 7, and then I want to do 5th root of 32, and then all of a sudden it gives me the 7th root. To do the 7 times the 5th root of negative 32, I do 7, and then times, and now I can activate my shift and my exponent key, get my 5th root in successfully, and then type the negative 32 for my radicand, and my calculator tells me that that's a negative 14. Without my calculator, I'd have to know that the 5th root of negative 32 is negative 2. And if you don't know that, that's okay. I'll give you a tool that you can use if you don't have a calculator handy. I always pass this out when I'm teaching an in-person class because I want you to know some common radicals. So I typed up a sheet of common radicals. I did like, here's the square root of 16 is 4. Why is it true? Because 4 squared is 16. Here, the cube root of 216 is 6. Why is it true? Because 6 cubed is 216. The 6th root of 729 is 3 because 3 to the 6 is 729. I might print this out if this is an online class. Otherwise, I'll try to pass it out in class. Specifically because I think looking at this, you start to memorize some radicals, and it's going to speed up the process so you're not so anchored to your calculator if you learn some things by memory. So the first few problems, the first 30 problems, are just doing radicals. Square root of 16 I could have done on my calculator. The square root of 16 is 4. If I have a negative in front of the radical, this either means I can think of it as to find the opposite of the square root of 36, or I can think of it as negative 1 times the square root of 36. They both would be adequate ways to think of this. The square root of 36 is 6, so I can think of this as either negative 1 times 6, or I can think of this as the opposite of 6, and they're both the same. The opposite of a number is that number with its sign changed, and negative 1 times 6 is negative 6. However you think of it, a negative in front of a radical, you do the radical first and then either find its opposite or multiply by negative 1, which is equivalent to finding the opposite. Problem 6, orders of operations. I need to do the square root of 25 first. Square root of 25 is 5, so this is going to be 7 times the square root of 25, which is 7 times 5. That's going to be 35. My problem 8, if I don't have it memorized, then either I use my calculator or I pull it off the sheet. The cube root of 27 is 3. there's not much I can do if I don't have it memorized. Well, there is. I could do prime factor trees, but that's just too much to do something so basic. 8 and 9 have odd indices and negative radicands. When that's the case, the answer is going to be negative. The radical is going to reduce to a negative number, and it's going to reduce whatever the cube root of 125 is made negative. The cube root of 125 is naturally 5. So I claim the answer to number 10 is negative 5, and I can check it. Anytime I write an answer to a radical, it should be the case that my answer raised to the index power equals the radicand. My answer is negative 5. I'm going to raise it to the index of 3 power, and if it equals the radicand, my answer is right, which it is. For problem 12, I'm going to not do the opposite version of this. I'm going to say this is negative 1 times the cube root of negative 27. It's less to write, and it works the same. I need to do the radical first. If the index is negative, then the radical reduces to a negative. If the index is odd and the radicand is negative, this reduces to a negative number. So this is going to reduce to some negative number. It's whatever the cube root of 27 is made negative, and the cube root of 27 is 3. So the radical part's going to reduce to negative 3. The cube root of a negative number is a negative number. The cube root of 27 is 3. And now I'm going to multiply the implied coefficient of negative 1 times what the radical reduced to, 3. The cube root of 1 is 1. The square root of 1 is 1. The fifth root of 1 is 1. The fourth root of 1 is 1. I don't have these on my sheet because I know that no matter what the index is, if the radicand is 1, it reduces to 1. The fourth root of 1 is 1. The cube root of 1 is 1. The fifth root of 1 is 1. Because 1 to any power is equal to 1. 1 to the fifth power is 1. 1 to the fourth power is 1. 1 to the third power is 1. If the radicand is 1, regardless of what the index is, it reduces to 1. Didn't do fractions in my examples. I'll just show you on my calculator. If I type the square root button for number 16, and then my fraction key, and then the fraction 9 over 16, it's very intuitive. The square root of 9 over 16 is 3/4. It turns out that the square root of 9 over 16 is the square root of 9 divided by square root of 16. The square root of 9 is 3, and the square root of 16 is 4. I have them on my sheets here if you need. But the square root of a fraction, you just separate the numerator and the denominator and do their square roots separately. So same deal with number 8. The cube root of a fraction, you can separate the numerator and the denominator and do the cube root of each. The numerator is the cube root of 8, which is 2. The denominator is the cube root of 27, which is 3. I could have done the cube roots on my calculator. Did shift cube root of 8 is 2. Shift cube root of 27 is 3, but I didn't. These, I'm just going to pull off my sheet unless I have them memorized. The fourth root of 16 is 2. The fourth root of 81 is 3. Getting close to where we're going to break to a part 2. It's already getting too long. But these aren't hard. 22 says 2 times the fourth root of 81. So that's going to be 2 times whatever the fourth root of 81 is. I need to do it first. The fourth root of 81 is 3. So this is 2 times 3, which is 6. 23 I think of as negative 1 times the fourth root of 16. The radical I have to do before the multiplication. I don't need my calculator if I have this sheet. The fourth root of 16 is 2. but I could have did shift exponent button, typed my 4, arrowed under the radical and typed 16. And the radical part reduces to 2. Now this is negative 1 times 2. The answer to 23 would be negative 2. (25) and 26 want me to do a root with a odd index and a negative radicand. If you have an odd index and a negative radicand, the answer is negative, and the number is going to be whatever the radical would reduce to if there was a positive. So 26 wants me to find the fifth root of 243, which would naturally be 3, but because the index is odd and the radicand is negative, I have to have a negative answer. 28 wants 3 times the square root of 49. I have to do the square root first. The square root of 49 is 7. And then I'm going to multiply by the 3 and get an answer of 21. I'm going to skip 30 and go down to 31 and 32. In both 31 and 32, they're square roots, so the index is the even number 2, and the radicand is negative. This right here, we're either going to say no solution, or we're going to say or we can more properly say this is an imaginary number. We just don't have any knowledge of those yet, or maybe you do have knowledge of those, the imaginary number I, but if you do, that's just knowledge you brought with you that you're not required to have. So if the index is even and the radicand is negative, saying no solution, not a real number, or its imaginary number is going to be adequate. The last few problems before we break. 34, even index, odd radicand, either no solution, maybe no real solution, no real number solution is a better word to say because there's made up solutions to these, but I'd live with no solution. So the difference between having a solution and not having a solution is whether the index is even or odd. If the index is odd and you have a negative under the radical, you get a negative answer. If the index is even and you have a negative under the radical, you don't get a solution. Similarly, 36 is one of these no solutions, or maybe no real solution is the really more mathematically elegant thing to say, but something that indicates there's no number that we know now that I could raise to the 6th power and get a negative answer. So I'm going to pause the video and we're going to do a part 2.